High in the mountains and deep in the polar regions, there exist massive rivers of ice that flow slowly but powerfully across the land. These are glaciers, some of the most incredible and ancient forces shaping our planet. But how can something made of solid ice actually move? Let's explore how glaciers work and what makes them flow like frozen rivers. A glacier begins its life as snow. In places where more snow falls each year than melts, the layers of snow start to pile up. Over time, the weight of the upper layers presses down on the lower ones, squeezing out air and compacting the snow into dense, hard ice. This process can take decades or even centuries. When the ice becomes thick enough, usually around 30 to 40 meters deep, it begins to deform under its own weight and starts to flow. Even though ice looks rigid, under immense pressure, it behaves a bit like a very slow-moving liquid. The ice at the bottom of a glacier experiences the most pressure and can bend and creep along the ground. Scientists call this process plastic flow. It is similar to how honey spreads slowly when you pour it, only millions of times slower. This slow, steady movement allows glaciers to slide down valleys or spread outward across continents. Glaciers also move by sliding over the ground beneath them. The base of a glacier isn't always frozen solid. Friction and pressure can melt a thin layer of ice at the bottom, creating a slippery film of water. This meltwater acts like a lubricant, helping the glacier glide downhill. In some cases, the glacier can move several meters in a single day, although most move only a few centimeters to a few meters daily. As glaciers move, they act like giant bulldozers, scraping and carving the landscape. They pick up rocks, soil, and debris, carrying them along over thousands of years. This process creates deep valleys, sharp mountain ridges, and even giant U-shaped valleys like those seen in the Alps or the Rocky Mountains. When glaciers melt and retreat, they leave behind this material in piles called moraines, reshaping the land permanently. Not all glaciers move the same way. Valley glaciers, found in mountain ranges, flow downhill through narrow paths, while continental glaciers, like those in Antarctica and Greenland, spread outward over huge areas. Together, they hold about 70% of Earth's fresh water, a vital part of the planet's ecosystem. Glaciers are also crucial for climate science. By drilling deep into glacial ice, scientists can study trapped air bubbles that reveal what Earth's atmosphere was like thousands of years ago. These ancient ice cores help us understand how temperatures and greenhouse gas levels have changed over time. Today, many glaciers around the world are shrinking due to rising global temperatures. As they melt, they contribute to rising sea levels, which can affect coastlines and communities around the globe. Monitoring how glaciers move and melt helps scientists predict future climate patterns and understand our planet as changing. Balance. So, while glaciers might seem slow and silent, they are powerful engines of change, sculpting Earth's surface inch by inch. They remind us that even the slowest forces in nature can shape the world in extraordinary ways. If you enjoy learning about nature's wonders and the science that drives them, make sure to subscribe to my channel How Things Work and comment the next topic you want to learn.